Okay, we're live. Tamer, take it away.
Hello, everyone, and welcome to the Audio Programmer Virtual Meetup, the first one of 2022. My name is Timur. I'm here with my co-host Josh, and we have two wonderful guests, Eyal, Amir, and Rachel Locke. Hey.
Hey.
Hello.
And yeah, thank you so much for tuning in, and it's a pleasure to be here. Really looking forward to two amazing sessions with our wonderful guests. And yeah, over to Josh. What do you have today?
Well, first I'd like to say Happy New Year to everybody, and hope everybody's having a safe 2022 wherever you may be. And this is a new location, as you may see. I'm actually in Florida right now, so it's a little bit warmer, and it's a little bit strange because this is the afternoon for us, where it's the evening. Normally the evening when I was in London. So good afternoon or good evening wherever you may be. And I'd like to give a thanks to our sponsors, JUCE, Sonnox, and Focusrite, for sponsoring the Audio Programmer Meetup. This wouldn't be possible without them, so thank you for your support. And also want to talk about where, if you would like to give a talk for the Audio Programmer Meetup, you could do so. The way to do that is to submit a proposal via theaudioprogrammer.com/submit. And one of these days, I'll actually work out a flyer where I can put the link actually on the screen when I say that, but I'll put that in the description of the video afterwards for you. So it's theaudioprogrammer.com/submit. And with that being said, let's go ahead and move on to our first speaker. So who's our first speaker, Tamer?
Our first speaker today is Eyal Amir, and he's an audio C++ developer, and he's going to talk about CMake for the uninitiated. And I'm really excited about that topic because I think pretty much every software project I've been involved in uses CMake. And it's kind of just ubiquitous in the industry. And it's one of those things that you kind of should know or have to know or are like really useful to know, but it's not really taught properly anywhere. Or like, at least I haven't really seen it being taught very much. And so it's kind of one of these things that you kind of have to magically acquire yourself, like, and teach yourself how to do it, which is kind of a rocky road. So I'm really, really happy that Eyal is here to, give us a little bit of a gentle introduction to CMake. And I think it's going to be a super cool talk, and I'm really looking forward to it. So Eyal, over to you.
Thank you, Timur, and thank you, Josh and Rachel. It's great to be here with you. All right, so I've started with a few slides. This is my first time ever actually making slides for something, so hopefully you'll find them reasonable. Let me share my screen. Okay, so this is my talk on CMake. So who am I, right? I'm a C++ audio software engineer. Some of my past stuff is Waves. I've made a bunch of plugins for Waves, X for Records, Deadmau5, Polyverse, Pitch Innovations, Artlist, and a bunch of other companies that I worked on commercial projects. I just started my new plugin company named Modalix with my partner Or Lubianico. And I'm also a musician, composer, keyboard player. You can look up my name somewhere and you'll find all kinds of weird progressive rock music. Also, I'm not a CMake expert. So I'm a pragmatic user of CMake. Hopefully I have some of the concepts understood well enough to help people get along with their journey. But to be honest, a lot of the stuff I've learned from people with more experience than me, like Ruben from the JUCE team, Alain Martin from Ableton, on some people even on our audio programmer Discord, like Bacon Paul, even Ilanda, like users who have more experience either on writing CMake code or configuring build systems and so on. So, but I do like workflow improvements. So I like all kinds of things that make your environment more solid, easier to reason about, or enable more features, etc. Okay, so what is CMake? It's a cross-platform meta build system. And it's the de facto standard to build C, C++ code. So if you get a random library, random C or C++ library from GitHub, there's a very good chance it will already use CMake. And that's true in a lot of different fields. It's also a rather basic scripting language, so you can write some sort of code in it, if statements, for loops, etc. So before we talk about what a meta build system is, we need to talk about what a build system is. First of all, you need to compile each source file, right? You got a bunch of C or C++. I got someone knocking on my door. 1 second.
Yeah, this is one of those
that had to be the funniest thing that could have happened. My neighbor knocking on my door.
Well, this is also this is a good opportunity for me to say to people, if you have a question, please precede those in the chat with the word question. So all in caps so we can see them clearly. But please feel free to ask any questions, no matter how beginner or advanced they may be. And I'm sure Eyal will know the answer.
Hopefully.
All right,
okay,
please.
Sorry about this pause. So you got to compile a bunch of source files, called the compiler for each of those. Then you got to link the object files that are created into a finished binary, like your app, plugin, whatever. That's it, right? Simple. We can all go home. This was hopefully a very productive session for everybody. But actually, there's a few other stuff. So you got to set optional compile flags, like maybe you have a logger that sometimes gets built and sometimes isn't. And maybe you have different flags if you have a different type of audio plugin or different type of app. So the build system has to somehow pass that along. Maybe you have a Mac app and you got to build a bundle to put all the files together. You got to copy something like a plugin into the correct system folders. You got to maybe generate code if you have a step from like another language that has to run before the C++ code. You might want to generate binary resources, like the binary data on a plugin, images, fonts, audio files, other things that the code needs access to. You might run pre-built scripts, post-built scripts, code signing. So this is a bunch of stuff, and this is just the stuff in your code. So usually there's also a bunch of other code that you have to build, like a library, if you're using JUCE or Qt or some other library that somehow gets linked to your project. That also needs everything that I've just said. And a lot of people ask, isn't my IDE already taking care of that, right? If you're using Visual Studio or Xcode, like those things are there. Like you can drag files into the IDE and it will know how to build them, and you have a settings page. And it does work, but as you know, if you've ever done it, it only works on a single platform. So Xcode will only work on Mac, Visual Studio will only work on Windows, etc. And it also forces everybody else to use the same IDE. I've worked at companies where, for example, the Windows project is a Visual Studio project, and it's very limiting because some people want to use something else. But then you're forcing basically everybody to add it the same way, even if they just want to build the code. It's also harder to share configurations. So you'll see that something that happens in bigger project is you might want to have a centralized way to do certain things so that all your projects do the same thing. That's very important when you're in a bigger company and there's a bunch of apps or plugins or something. You don't want to have each thing configured separately. And that's something that's harder to do in an IDE. Even though IDEs do have that feature, it's not the most convenient thing to just bring in some configuration. So some of the people here are using something like JUCE, and you're familiar with a tool called the producer. and you're asking, isn't the producer doing this for me, right? Because it does generate, Visual Studio projects, Xcode projects, make files on Windows, on Linux and stuff. So the problem is it only supports a specific set of IDEs. For example, when I started to use JUCE, I wanted to use CLion, and it wasn't supported. But then later, as support was added, it wasn't complete. And then I later wanted to use something like Visual Studio Code, which is a very popular editor, and it wasn't supported. So I had to wait for that support to be there, and it's, I guess, hard for somebody like the JUCE team or any kind of a library development team really to support everything else. It also doesn't allow to share configurations between projects. Like sometimes I had to update all my projects to add a little thing because I needed a new flag, and then it needed to be added everywhere, and it was pretty hard to remember where it needs to be and where it doesn't have to be. And also, more advanced build configurations are either hard or just plain impossible, because it only supports a very specific way of doing things. So CMake to the rescue. It's cross-platform. It runs on almost every platform that C or C++ can work on, even mobile, Linux, etc. Supports all the major IDEs. Either you export to them, or they just already know CMake and they can open it natively. Can be configured or built through the command line, which is useful if you have like an automated build system. Supports text editors like VS Code. And the most important bit for me, which we'll probably go over a lot in the live demo, is that allows to have the concept of dry, don't repeat yourself, in the build configuration. Okay, so let me switch over here to my to the demo thing. And now we're going to start seeing some cool stuff. So I'm going to use CLion quite a lot, but I'll also use a few other things just for the demo. CLion is specifically my favorite IDE to use, also because it supports CMake natively, even though there's other reasons. So, so let's start with the hello world thing. Yep, there you go. Great. Hopefully this is clear enough. How do I zoom this? Okay, hopefully this is bigger. So, so this is like the most basic project you can do in CMake. You have to declare the version of CMake that you want to be using. You want to declare the name of the project, the C++ standard, and then you add some target as an executable, and you give it source files. This is pretty obvious, hopefully, and pretty much the basics that you think about in any kind of a build system. And you can just build it and it will work. And so you can also like generate something. So if I go to my terminal here, I can do something like, hopefully this is big enough, so I can do something like CMake -g Xcode -b build. And that will generate, oh, not build, let's use another build directory. So build Xcode. And this will start generating a project for my favorite IDE, like Xcode in this case. So it takes a few seconds, it generates it, and then right here I will have a build Xcode folder, and there will be a hello world Xcode project in there. And the same thing can work if you're using Windows. You can do something like, I don't have Windows right now, but you can do something like Visual Studio 16 2019 and get a Visual Studio project, etc. So this is a very simple way to just get going no matter what your IDE is. And stuff, if you're using something like Visual Studio Code, it's a big favorite of mine. So Visual Studio Code allows you to just drag like the folder in there if you have these extensions. So you need something like the C, C++ extension, the CMake extension, and the CMake tools extensions. And then it will also allow you to do something like tap Meetup, hello world, and just drag the folder in there. And if you have a CMake file in there, it should automatically configure that and just allow you to build, right? You see it automatically discovers all the targets in there and runs hello world. Usually it also will pick up like everything in the code, and you can just browse and debug and work like you do in any other IDE. So that's a really nice bonus. So let's look at something more advanced. So let me close this project and let me open another project called App with Shared Library. So this is like my next step usually is, I don't just write an app. I have some library that I wrote that I want to share code with. So what I did here is I did something called add subdirectory. So I connected another directory. In CMake, a directory is just any directory that has a CMake lists.txt file, which is where we describe the build process. So I can do something like add subdirectory and add shared code, right? And shared code is just another simple folder that has, hopefully this will be visible enough. Let me get this down. So what this does is it adds the library as a static library with the source, shared code.cpp. And then it has the include directories because usually, we have to have some way for the user of the library to find the files, to find the source file so that it can include them. So our main project will just do something like add subdirectory, right? So first it knows about this library, the static library. Then it adds the executable, and then it links them together. And if you look at the code, right, the shared code has one amazing function. It's called hello world from lib. Here you can see the amazing implementation of this function. And in main, like in our app, all we have to do is include this, which is now in our include directories. So that was passed to us by the library, and then we could just build, right? So that will build, find the library, build the library, and call hello world. So far we're in like the most obvious basics to just build C++ code. But let's do something more advanced, right? So usually you don't just use your own code, you use other people's code, like libraries. And a big question is, how do you even get the libraries? Do you use like the system package manager? Do you copy them into your repository? Do you use a Git submodule? There's a bunch of ways, but I will show like one of my favorite ways to do this. So I have this thing here called CPP CMake Starter, just a folder that I have. And this is like a template I made for myself so that I will immediately have some dependency, because I know that just setting up a dependency is complicated. And in this case, the dependency is a really good HTTP library, right? That allows you to write really simple HTTP clients or send messages and servers. So to use this, I've used a really nice CMake script or CMake library that's available for free called cpm.cmake. And what it does is you can declare these dependencies and where they're from. So you'll see that it says that add this package, right, from GitHub, right? So it will actually go to GitHub as a part of the build process to branch master, grab this library, and configure it already automatically for me because it's already using CMake. So when I run this and CMake configures it, it will do something like you can see in the configuration log. It says adding package cpp http lib. So I didn't have to go to this. I didn't have to call any extra command. I just called CMake -g whatever, and it ran this as a part of the script. And this is really useful actually, because then you have a very easily reproducible environment if you have other dependencies in there. And so that's all I needed to configure this. And in my code, so I have, all I had to do is include HTTP lib in there, right? You can see I didn't have to know even where it is, because I think the CMake file already configured the include directory for me. So once I did something like target link libraries, my app with HTTP lib knew to pass in the folders of where it is. So it just says find HTTP lib, and the compile system or the build system knows how to resolve that. So in this case, I'm just sending an HTTP message to get google.com, and this is what google.com looks like. I don't know if you ever went to it, but obviously everybody knows that this is the usual output you're expecting. So I like to start like this, because usually I will, when I start out, I will bring in a bunch of stuff. Maybe I will bring in JUCE. Maybe I'll bring in, Boost. Maybe I'll bring in a unit test system or unit test framework, which we're going to talk about in a second. So this is really my kind of my first steps, right? Make the project build, make your app. In a second, we're going to talk about like audio plugins and stuff like that, and how it works with that. But before that, do you want to stop and ask me like some question before I run on?
So I don't think you actually have questions yet on the chat, but I'm very happy that you're using CLion, because that's my favorite IDE too, and it supports CMake natively. So you just open it and it just works, which is pretty cool.
Yep.
And it works on Windows, Mac, Linux. So that's kind of what I use as well. But there are no questions yet. But if you have any, please feel free to post them on the YouTube chat, and I will ask Eyal those questions.
Great. Okay, so let's go. So now that we've talked about the basics, to me, like it's, I guess this part, like fetching the thing from Git, is not as basic. But let's go deeper now to how we configure audio apps. So starting JUCE 6, JUCE started to support CMake natively, which I thought was amazing. I was so happy they added that. And I have a repository that's publicly available on GitHub with some configuration starters for JUCE, because JUCE introduces a few things, well, not just JUCE, but plugins introduce a few things that aren't as straightforward. So let me load that. And this is a more complicated CMake file already. There's other things that we have not talked about yet, but let's go through some of these and see if we can kind of extract what this does. But the first thing you'll see when I loaded this is that there's a bunch of plugins that gets loaded in as targets. So this loads see, I have a MIDI effects template. I have just a minimal plugin template. I have a plugin template with a custom module. I have the unit test runner. So it builds a bunch of targets. And that's one other thing that CMake can do that other build systems don't always know how to do, is there's multiple things connected to the same project. Sometimes they get built together, and sometimes they're just a convenience or something that the developer needs, like the unit tests. There's something that you want to have around with you inside of your development projects, right? So you don't want to open a new Xcode project or Visual Studio just so you can do the unit tests. That would be annoying. So these are a few things that have more been things that I tested when doing plugins. So for example, you'll see there's stuff like the minimum Mac OS target in here. There's a flag that you can pass in whenever you're building universal binaries that will support M1 and Intel on Macs. This is a Windows configuration that has to do with static or dynamic linking. these have to do with how the source folders show up when you open like an Xcode project. And here, this is the interesting bit. This is where I bring in JUCE, right? So I've connected my project to this version of JUCE, and it will just go to GitHub automatically, fetch that into the build directory, so into like a temporary directory inside my project. So I don't have to do anything to have JUCE. Like if anybody grabs this, you don't need to have JUCE. It will get it for you. And there are ways to configure that, which I will go over in a second. So so you add this, and then you add like other directories like apps, plugins, and unit tests. So so let's go over a few of other things that this thing has allowed me to do. One thing is stuff like code sharing. So for example, I wanted to have that my examples have a really clean, minimal interface, right? So for example, the minimal plugin templates, this is the entire code for the minimal plugin templates, or the header. It's something that inherits from this base class that came out of nowhere, it seems. And one function called process block that in this case does nothing, just clears the buffer. But I wanted to see if I can make something that, at least from the user's perspective, will have as little code as possible. But to do this, I needed this base class. And this base class is just something that just covered all the boilerplate that the plugin configuration has, like save and load presets, like declaring the number of programs, like all these kind of stuff you usually have in the interface. And I brought it from a custom JUCE module that I made. Right, so it's a JUCE module that has that base class in there, and if I go in there, it will show that it's got a bunch of overrides on the JUCE audio processor class. Some of these are just like empty implementations because most of the time you don't even need the function to get some sound. So this is just something that I always use. I'm using this base class all over the code base. So I encapsulate it in a JUCE module. And I structured it along with the repo. So when I declare the repo, I just add the modules as a subdirectory. When I go in there, in the models, I have something like add custom module tests, share processing code, and share plugin helpers, like 3 different shared code libraries. And then when I go into one of the plugins, like this minimal plugin, all I have to do, just like we've seen before, is I link against it. So I can link against this thing, shared plugin helpers, along with JUCE and other JUCE things. So this, and the way, now that I've done this, it's super easy. So now all over my code, or all over this repository, and soon you'll see even in other repositories, I will now have access to this code. I don't have to rewrite implementations of this very trivial base class, and I don't need to define complicated ways to link against it. I can just link against my custom module. It's right here. And something like my MIDI effects template, which would look almost exactly the same, also links against it. And then this, in the source code, it can do something like that. So now my MIDI effects template is almost as clean looking as the minimal template, right? So this was like a very quick way to just share stuff, right? You just you declare a module, and this module is now known to everybody who knows of your CMake project, or this library, really, right? And then you can just bring it in, whenever you fancy some of your own code to be in there, just like you want to be using JUCE. So so this is like the basics of the setup. If you want to ever go in there, it's on my GitHub. You can observe these examples. You can build them. Hopefully, it will be trivial to just get to build. But not. There are actually more complicated situations. So let me close that. And okay, so one of the things I like to do is you know what, once I've configured how JUCE builds with all the Mac flags and Windows flags and blah, 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 I don't want to do this again. I feel like I've found the best flags. Like this is how I want to make JUCE apps. And I want to keep using those same configurations. So here, for example, I have another repo that I made. Oh, oops. Okay, so if I have another repo, and this is way more minimal because this just brings in the other repo, right? It just builds up on the previous one. And this will just bring all these configurations, and that's it. I can just go ahead and add my plugin subdirectory, which will just have a simple test plugin that can also use shared plugin helpers and use it in the code. So I've just passed along all this information to my next project, right? I can just share it. I don't have to copy paste code from projects. I don't have to use Git submodules that will require additional commands. This is in there. Another thing I've done here, which I haven't talked about a lot, but you can also define functions. So for example, I've found that this step here is actually common. I do this all the time. I always set the same compile definitions on a plugin. So you can just, like any programming language, you can define a function, right? Set default plugin with the name of the target, and then it will do these things to this plugin. So if I go to CMake, the CMake of the plugin, I just call this JUCE function to configure JUCE. I add the sources, and then I call set default plugin, and it will just add the default stuff, which will make it really easy for me when I start the next plugin, which will very likely have the exact same things in it. So so that's all good, but you don't always want to do what I just did, which is connect to GitHub, because GitHub might take a while fetching the things, but also you might actually want to be making changes to the dependency. If you have like a complicated repository with you know, a shared library and another shared library and a few plugins, you might actually be you want to be able to addition like library changes with your app changes. Like you want to test everything together and making sure that works. So what you can do in this case, I like to set up something I call a workspace, even though a workspace can also just be a command line, things you pass in the command line. But what I do is I define a CMake file that just sets a bunch of flags. This is just so that I will not have a very complicated command line to call. And all I do here is I tell the dependent repo that we've just seen. So I'm adding it here. But before I'm adding it, I'm just telling it where the source of JUCE and the source of the CMake repo will be. So instead of fetching it from somewhere in the universe, it's gonna go to my local drive, which will mean that I can now test like Git commits. I can bring in branches. I can make local changes. I can do anything that I locally do, and this thing will always know to resolve all these different dependencies, right? So I didn't have to set up a Git submodule command for this to happen. I didn't have to call some external package manager. CMake will know to resolve this, and whenever somebody else just grabs this repo without this workspace, without these two extra commands, then it will just go to GitHub and get the versions that are listed inside the actual repos. Like in this case of JUCE, it will be the develop branch. So this is what I do to set up I guess more complicated environments, because sometimes I will have a lot of these different repos that are dependent in each other. Some are mine, some are other developers, some are external. So this is a really nice way for me to configure an environment where I'm abusing everything. I can test forks and not be overwhelmed by the complexity. Okay, so one last thing before I'll finish this is unit tests. So this is something else that people really like to do, like unit test their code. So CMake makes it really easy to do unit tests. So here I said something like if build unit test. Build unit test is just some configuration flag that you can pass in. Do you want them or not? And then I added the tests in like a subdirectory. So the test directory did some configuration, but then it brought in Catch2, which is my favorite testing framework, included it, and then it just built a JUCE console app so that I can run the tests in it. So it just builds a dummy app with almost nothing and links with Catch2. And then Catch2 has another really friendly CMake command called catch discover tests. So let's see if we can run the test, right? So in one of these targets that open up, I have something called a unit test runner. So let's run it. It's going to build and run, and all the tests pass. Let's see those tests. By the way, they're not very interesting. They're just checking that JUCE, JMin, and JMax are doing the exact same thing like the stud versions. So one test case tests the min version, one other test case tests the max version. So the cool bit is not only that you can run those manually in like a console app, CMake and CLion, by the way, too, will discover those tests because we've ran the catch discover test command. So for example, you can just call something like ctest, and you can see that it ran all the tests, right? So it does it even without knowing what your framework is. It kind of gets configured automatically with it. And if I'm using something like CLion, it gets even more advanced because CLion will detect that I have ctest configurations, and you can even do stuff like pick which tests you want to run. If you're debugging tests, you see it just picked up the names without me having to write them into the IDE. So it's a very, very nice way to kind of integrate all your unit tests into the same workflow. Okay, that's it. Hopefully it wasn't too heavy, and if there's any questions, happy to answer.
Yeah, thank you so much, Eyal. That was amazing. That was very, very, very helpful. Just actually curious, if you're aware of this, you go to CLion, there's also actually a way to run individual tests directly in there. You can just do the little green arrow next to the test, and it's going to run it.
Yes,
and
absolutely.
Things like
yes.
that. So there's like cool Catch and CLion integration going on. Actually, Catch is also my favorite testing framework. So yes. Yeah, we have a few questions. FF Audio is asking, does the GitHub repo need to be prepared for CPM? That's the CMake library we talked earlier about. Or is it just having a CMake list.txt?
It just needs a CMake list.txt. Like it will under the hood just bring it in and call add subdirectory or something on it. If it doesn't have it, like if it's just some other repo that doesn't have it, there's or if you don't want it, by the way, there's situations where it has a CMake list, but it does things that you don't care about. You want to do your own configuration. There's ways to configure this in CPM. Like if you go to their GitHub page, so there's a few like flags, like download only or stuff like that.
Cool. And I would like to piggyback on that question myself and actually comment on CPM. So I've actually never heard about it before. So it's essentially like a package manager for CMake, right?
Yeah.
Can you say again maybe where we can get it from? Like where is it available? Like the URL? Maybe we can later add it to the video description or something.
Yeah. It's just GitHub cpm.cmake. You can look for that. It's an open source, free to use library, and it essentially just wraps things that CMake already has, but it adds some extra bit of logic so that if you have a complicated chain of dependencies, then it knows how to resolve them, which pure CMake will need a bit of help if you just do. This kind of looks at your tree of stuff and says, oh, some library back deep in the tree search for this thing, and I can fetch it from the root, so I'll just fetch it once and not like a million times.
So that's really cool. Do you know how how CPM compares to like other C++ package managers? For example, you're aware of Conan or things like that?
I'm not an expert on it. From my little experience with Conan, VC Package, and some of the others. So first of all, CPM is a part of CMake, so nobody has to install it. So that to me was like the best advantage. Like if you call CMake -G your IDE, it's gonna work. Like you don't need to ask the user to install extra software, and like it's so that was like the first bit for me. I think Conan and other things in that field are more advanced. Like they actually they do what this does and more, but they also require some infrastructure because you need to create Conan packages for everything. Like there's some setting up to do, which I'm not as well versed in. So
cool. Well, yeah, definitely learned something today. Thank you very much. We have one more question by Paul Davis, who's asking, JUCE requires some specific configuration to build plugins for Linux correctly. Can the technique in this template deal with that?
Yes, 100%. So for example, my repo hopefully has the right flags to build for Linux already. Like there's a few things that you have to like disable the web browser or something for it to build. But yes, and you can definitely, not only that you can do them, you can pass them and then, have one function that says configure Linux plugin the way you want it to, and just reuse that everywhere.
Okay, well, that's really cool. There's a follow-up question from FF Audio. Can you reference a certain hash in CPM, or is it always head?
Yes. You can pick a hash or a brand. Yeah. It's very, very much like most, NPM and other like package managers that have similar functionality.
Cool. And also I'm wondering, so using JUCE and using like JUCE's native CMake integration. So there's a project that I'm involved in where, before JUCE had CMake support, there was this other project called Fruit by Alan Martin. Have you used this? Do you know like how it kind of compares to like the new kind of JUCE CMake support that's kind of official?
Yeah. I've actually used it a bit. I was quite a bit actually before the native support was there. So Fruit is an amazing project, by the way. Shout out to Alain Martin, who's again one of my guides along the path of CMake. So his thing is actually was made first of all to take an existing producer project and just do an as-is conversion. And I think that the newest version of Fruit also generate a native JUCE 6 CMake instead of what it was before, but he can probably explain more on it. The best thing about what he does is that if you have an existing thing, you can get an exact translation of how your project has been before, which is important because sometimes changing the build settings, if they're not exactly the same, some weird problems could show up. So you want to make sure that you don't ruin your product by switching the build system.
Cool. Yeah. So it seems to me that CMake is very quickly becoming this thing that you just kind of have to know about if you work in the audio industry. I remember a big company that I worked at many years ago that I shall not name actually was not using it, and they had like an Xcode project and like a Visual Studio project, and every time you had to like add a new file, you had to like add it to the Xcode project and like start the PC, add it to the Visual Studio project, and you forget to do that, and everybody's projects break, and then they kind of migrated to CMake, and it was quite challenging because of the kind of size of the code base, but in the end, like really the only way to go. And ever since, like I've seen more and more companies and projects migrate to CMake, and whenever I do stuff, it's just because also I use C-Line, like I just start with CMake, and I think really this is the way to go. So thank you so much for introducing it so well, and especially with this kind of audio plugin focus, because I think this is kind of missing in some of the material that's kind of out there on this topic. So that's really cool. I'm going to wait for another second. If anybody else has questions to Eyal on the YouTube chat, please ask them now. All right. It doesn't seem like we have any. So again, thank you so much for the talk. It was really, really cool. And I think we all learned a lot about CMake today. All right, and I'm going to pass over to Josh.
Hey, everybody. Thank you very much for that awesome talk, Eyal. One that I will probably reference myself very often, and I'm sure many other people will as well. And now we're going to move to our second talk of the evening. But before we do that, wanted to make a quick announcement. So as many of you know, we have been doing this audio programmer meetup for nearly 2 years now. And so it'll be 2 years in March. And Timur has been my co-host for the past 2 years. But now Timur has decided that because of various reasons that he would like to retire for a bit. So he's going to still be a part of our extended audio programmer family and still be popping in from time to time. But what we want to do now is we want to pass on the torch, and we are actually passing on the torch to the next person we're speaking to, who is Rachel Locke, who will be joining us as our co-host. And Rachel and I have actually known each other for a couple of years. She's actually the person who was initially responsible for helping me get into the industry out of university back in 2018. And we'll go more into that story. So this is kind of a virtual handing or passing of the torch from Timur to Rachel, and we're very happy to have her with us as co-host, new co-host of the Audio Programmer Meetups. She is yeah. Would you like to say a few words?
Yeah. I can just say a couple of words. So first of all, thank you so much, Josh. And I've been co-host here for almost 2 years. It's been a lot of fun. We had so many great guests, so many great talks, so much fun. So thank you everyone for listening, being part of this, and thank you, Josh, for having me. I think just kind of to briefly explain what's going on, like last year was kind of tough and I have quite a lot of stuff going on. So I'm just kind of trying to really quite radically reduce the amount of commitments that I have in order to stay sane and just not be completely stressed out. So unfortunately, this is kind of one of the things that I have to take a step back from a little bit, but it doesn't mean that I'm completely gone. So I'm certainly going to appear from time to time here on the meetup and talk about stuff. So I'm very much looking forward to that. But I'm also very, very excited to pass on the torch to Rachel. I think it's a really cool thing that we have, some new stuff going on here on the meetup. So I'm, very much looking forward to Rachel, carrying on the co-host torch. And
yeah,
and that's pretty much all I have to say for now. Yeah.
Yes. Thank you so much, Timur, for all of the support and that you've helped us with for the past 2 years. And you've been really amazing as a co-host. And I would say I'm going to miss you, but you're not going to be too far away. So it's not like we're going to be going anywhere. So I'm not going to say I'm going to miss you, but we're really proud to have Rachel here with us. She's newly a research software engineer at Vochlea, which is a startup music tech company in London that's doing some amazing things, and also a recent graduate from the University of West London with a master's in digital signal processing. So she knows a lot about creating digital signal processing and a lot about research. And she also, this isn't her first foray into the music tech industry. But I'm going to leave that as a surprise for her to unveil when we start talking about her story. So enough of me talking. Rachel, how are things going?
Hi there. Thanks, Timur, for passing the torch to me. I'm really thankful to be invited on board to this meetup and just looking forward to what the future holds. We've got some great new ideas we've been discussing.
Yeah.
Really excited to get started.
Yeah, absolutely. And speaking of getting started, it'd be great to hear a little bit about your story. So what got you into music tech? What got you interested in this career path?
Sure, absolutely. So my journey with audio and audio tech, I guess, in general, starts about 10 years ago, actually. It's been like quite a long journey to get to this point and decide exactly the direction that I wanted to go in. So I started out at a place called Deep Blue Sound, and it's like a music tech academy in Plymouth, but they now have academies in Berlin, Bristol, and in Cornwall as well, I think. So I started there doing a diploma in creative DJ and electronic music production. And at the time, I think all I wanted was to be a superstar DJ. And I absolutely loved acid house. I just discovered acid house, and I just wanted to play that in clubs for the rest of my life. But as time went on, I realized that perhaps I wasn't suited to the sort of the working hours and the lifestyle of a DJ, and I preferred something a bit more like staying in one place and not so much traveling late nights. So I got more and more into sort of performance, but not necessarily DJing, like live performance, synthesizers. And I was wondering like where this journey was going to take me, because I decided that I didn't want to have, you know, the lifestyle of a DJ, like I said. And we were lucky enough at Deep Blue Sound to be exposed to these really incredible, well, they're really like industry legends that had gone on to be lecturers. And they were just so multi-talented. And we learned a lot about experimental music and things like graphic notation, control systems, MIDI, and like how all of these things tie into like mathematics and psychology and philosophy. So we were really lucky to have the lecturers that we had there. And so yeah, I didn't really know where I was going to go with it next, but I decided to stay on and do a degree with them. And that was in music and sound technology. And I realized that I wasn't really enjoying the kind of studio-based or like live sound side of things. So I was just leaning more and more towards sort of either like installations, started learning a bit about Max MSP and Reactor, and started looking into like maybe ways that I could build my own tools for music creation. But at this point, I hadn't heard of anything like JUCE or C++. I was just looking into like, oh, okay, there's these like modular programming languages where I can start like piecing things together. And yeah, that up to that stage.
Yeah, but then you made a big move into music tech, didn't you?
I did. So I graduated from the University of West London from my undergraduate. I did a top-up year there. That's what joined me from Plymouth to London. And I spoke to, I think it was Angus Hewlett. I hope I'm saying his second name right. And at the time, I'm pretty sure he was the Chief Technology Officer at Rowley. So a position became available working with the JUCE team actually as software sales and marketing. So it's essentially like some social media involved, some support for the JUCE team, some writing simple articles like about the newest developments in audio development. And so I was there for about 6 months. And this is actually how I met Josh, because at the time Josh had like recently begun making the JUCE tutorials, and we didn't really have anyone like that at the time that was like churning out JUCE tutorials quite in the same way that you were. So that's how we met, just through like some community outreach at the time. And me and Josh ended up meeting for the first time, I think ADC 2017.
That's right. Yeah. I was still
Yeah.
a student. I was still a student at Goldsmiths University.
Yeah.
Yeah. And
so I was helping to plan that particular ADC.
Mhm.
And yeah, absolutely loved it. And I've been every year since, I think.
Mhm.
Yeah, really look forward to that every year. And I realized while I was working at Rowley with the JUCE team that I would much rather be doing what they were doing rather than the sales and marketing work that I was working on at the time. And I realized because I didn't have like a mathematical background or a computer science background, that the only way for me to do this is to pursue a master's, like a engineering master's. But it's quite difficult to get onto these kind of masters if you don't have some like prior qualifications in computer science, electronic engineering, or physics, something like that. So I went to the University of West London because they were accepting people from music tech backgrounds, giving them a chance to excel in the engineering masters, but just hoping that they could, in their own time catch up on all of the sort of mathematics and computer science stuff that they would have missed from not doing an undergraduate in that subject.
Now, what was that like?
It was really intense at first. Our first module was actually mathematics, DSP mathematics. And the last time I'd done mathematics, I think, was secondary school, like GCSE level. So I had to join a lot of undergraduate classes, just like in my spare time, to try and get that, like those fundamentals of engineering mathematics. I didn't have any, even like calculus background, linear algebra, all that kind of stuff, had to learn from scratch. And yeah, it was really tough. And there were times in that first semester where I just thought, it's not possible for me to do this coming from an arts degree. But yeah, I really think.
What was the most challenging aspect of it for you? Is there any part that you could pick out that you say that was really the most challenging aspect?
Just the learning curve of digital signal processing.
Yeah.
Like it's really incredibly difficult at the beginning. I think now in hindsight, there are things that would have made it easier. And there could have been sort of like a precursor to the course where you learn some fundamentals if you don't have the background at all. And I do sometimes wish that I'd chosen a more technical subject at undergraduate, but now I can see that having, the music tech background is really important as well. And if I didn't have that, that would have been something that I'd have to learn now, if that makes sense.
And were you learning how to code concurrently with the DSP, or did that come later?
So in the first year, we used a lot of MATLAB with the DSP module. And then, so I did it part-time. That's why I'm saying first year and second year, because I just felt that would be better for me with everything I had to learn. I actually ended up stretching the masters over 3 years. And I'm really glad I did that because it just allowed me to really like take a deep dive into all of these new concepts that I was learning. Yeah, I would say that mainly MATLAB in the first year, and then we started like audio C++ in the second year.
Mhm.
But I'd already been looking at C++ for a while, just through being interested in audio development.
Moving from MATLAB to C++, did you find that challenging, or what did you think of that transition?
So I'd already been looking at the fundamentals of C++, but I would say that, yeah, MATLAB is simpler in terms of not being heavily typed. Well, in a lot of ways, simpler. But I don't know, there's difficulties with both. But I found the only way to learn C++ for me, because I tried for a long time just on and off and found it very difficult, as most people do, but is to find a project that you really care about. Something like, for example, building a simple plugin will make the code less abstract for you. Because I find code at the beginning can be very abstract if you're not building a project where you can like either visually see something like a project or hear something like an audio effect that can really help to cement it.
And what was your first project?
My first project.
Your first C++ project.
An address book.
An address book.
Yeah.
What about your first audio C++ project?
Oh, I think it was a simple delay plugin.
Nice.
Yeah, just with some feedback control and delay length.
And did you build all of the parts of that, the circular buffer and the delay lines? Did you build those from scratch yourself, or were you using pre-built components?
So yeah, I built them myself, but I was using JUCE. Yeah, I wasn't going raw C++.
And how did you learn how to do that? How did you learn how to build the circular buffer and how to start going through that? Was that something you had learned through class, or did you have?
So yeah, somewhat learned through class. We did like a more advanced audio module where we looked at things like delay lines, but also Eric Tarr's book Hack Audio helped me so much. If you've heard of this book, it's basically Eric goes through pretty much every audio effect you can think of, and he codes it up simply in MATLAB. So if you're learning something nice you can do is go and either read the book, or he has YouTube where he makes these short, like nice videos of him coding up audio effects. And a nice project is to try and translate what he's done in MATLAB over to JUCE C++, because quite often I find that prototyping audio effects in a language like MATLAB or Python is nice to do before you then implement it in C++.
And some people may know this, but Eric Tarr is a legend.
Yes, for sure.
Well, he's been on the channel a couple times, and he also recently came out with a Python conversion for all of those for all of that code. So all of the code that he has in the book, and you can actually look at the GitHub repo. I think everybody has access to the GitHub repo where you can actually see this without the book, but he's recently done Python conversions of those, and you can check them out on his, I think it's Hack Audio, is github.com/Hack Audio is where those would be. But Eric is also a fantastic teacher. Teaches
nice.
Yeah. So great. So Hack Audio by Eric Tarr. Yeah, that's fantastic resource. One that I've used to learn digital.
Yeah.
Myself.
Absolutely. There's another book called DSP First. It's kind of hard to get hold of, but it's very readable. I found that when I was starting out, a lot of the books on DSP, like there's a book called Signals and Systems, which if anyone's into DSP, I'm sure they would have heard of this book, Alan Oppenheim. This book is just very, very daunting if you look at it as someone just learning DSP for the first time. So I would definitely recommend DSP first over that, if you can find that.
And for people who are maybe haven't even done any sort of DSP before and want to get into the math aspect, where would you say is the best kind of insertion point into that? Would you go for like linear algebra, or would you go for just GCSE level algebra?
Yeah, good question. I would say that I think there was a textbook that we followed when I went to one of those undergraduate classes that I was telling you about to learn the fundamentals of engineering mathematics. And I think it's something like Introduction to Engineering Mathematics, but there's a few concepts that really like bolster up DSP, which are really good to go over, things like linear algebra, matrices, calculus. And I think these concepts are generally covered at A-level. So a kind of A-level engineering mathematics textbook. I'll try and remember the one that I went over because it has really great exercises in it and answers. So you can like learn a bit about that concept, and then you can do the exercises and like check your answers against it.
Interesting. And what would you say the learning experience was like? I know we might be putting University of West London on the spot here a little bit, but in terms of, so recently coming through the education pipeline and stepping into the industry, do you feel that generally what you learned prepared you for the industry, or did you feel that you had to rely on some of the past experiences before you went to university, that helped you understand what the needs were to fill those roles?
I would say that taking on something like this without a background in engineering, there's going to be an awful lot of distance learning or self-learning, whatever you want to call it. They're going to teach you the concepts, but you'll have to put in the work sort of outside of the degree. There were a couple of people on my course that came from computer science or engineering background, and I noticed that for them, the experience was a lot smoother because they just had these like fundamentals that you really need to understand some of the other concepts. So we were just like fighting to like stay in the race sometimes, especially when it got to things like Fourier analysis without having a mathematical background. But it is possible. Like I want to be an advocate for like showing that people can like don't have to be from the classical background if they want to pursue something like this. Like there are different routes into it.
And I can imagine being in a group that you have some people who are better developers, maybe some people who are better at mathematics, that there's a little bit of osmosis. So I always think about the importance of having people around you who are working on the same types of projects, have similar sorts of interests, right? It seems like that, because it's very difficult to get all of this just out of your own brain. Sometimes you need perspectives. That's one thing that I've found.
Absolutely, it's really important, like to work together in something like that.
We have a couple questions
Sure.
that I'll throw over to you. So George asks, do you know what the opportunity, I'm assuming these are program opportunities, are for audio processing research at the University of West London. He's considering it for his PhD. Any ideas on that?
Right. So for a PhD, I don't know if it would be my first choice. I know that obviously I'm an alumni of there, so they do have an excellent School of Computing and Engineering. But I would say that in terms of audio research, audio tech research, there's not too many people available to supervise your PhD there. For example, I say that because quite often we had to have people come in, say from Queen Mary, to teach certain modules on the course that were more specialist. So I would probably recommend Queen Mary for that. I know it's like a center of excellence for that kind of research. But if the University of West London is somewhere that you're interested in attending, then I would definitely go and speak to them. There's a guy called Christos that is he's the head of the course that I did, the MSc. So I definitely try and speak to Christos if you're interested in that.
Great. And we have a question from Jesse asking, when you were learning calculus or other math subjects, were there hands-on audio programming projects that allowed you to apply these topics? So.
Oh yeah, that's a good question. I would probably go back to the Eric Tarr book for that. Yeah. I would say for calculus though, maybe I didn't do any like hands-on audio projects with that. Apart from, well, there's things that it applies to, like when you get deeper into the DSP mathematics and you start doing things like the Fourier series and convolution. I'm sure that there are some like interesting audio projects for that, but me personally, I just would do like mathematical exercises based on them. But I would be really interested if there were audio projects that pulled in those kind of concepts.
Yeah. And I guess that goes into, that relates to another question from Cameron, who asks, and this may be to be determined because you just started or starting with Vochlea, which is how often are you using these DSP fundamentals on the job from day to day? How often do you anticipate that you would be using this? So you're going to be a research engineer.
Yeah.
Can you talk a little bit about what that will involve?
So yeah, that will probably and hopefully involve me using the DSP side of my education quite a lot, and kind of combining that with machine learning research to find like clever ways to develop new features or improve existing features within the application. So if people aren't familiar with Vochlea, we make a product which is a voice to MIDI. So you can use your voice to, if you have a music idea in your head and you're not necessarily classically trained, you can use your voice to live sequence your musical ideas. So I have been looking at ways, especially in my master's dissertation, to sort of streamline the process of training triggers with your voice within Doubler, and then like using those triggers, whether it's like beatbox triggers to sequence drums or singing or humming to create synth lines, looking at ways that you can improve either the pitch detection or the classification of different drum triggers.
So are you getting into the machine learning aspect of this as well, or do you just meet at the point where you're doing the DSP, or are you responsible for learning some of that aspect as well?
So my master's dissertation was completed sort of in collaboration with Vochlea. And that was called Automatic Determination of Vocal Percussive Classes Using Unsupervised Learning.
Wow.
And essentially it's, I was building a clustering pipeline in order to group different vocal percussive classes. So if you have some essentially beatboxing of different drums where they're using unsupervised learning, you can determine like what different groups of drums are there. So like, is someone emulating a kick drum or a snare drum or hi-hat?
Mm-hmm.
And that work was done because within Doubler, you can train different triggers. So you can use any sound you want to train like bass drum, kick, hi-hat, snare. And it would be nice if we could build into the product like some real-time way of separating those different sounds in a stream of beatboxing. That would be useful for a lot of feature development and applications in the future. So that's what I was working on, building a pipeline from a data set, pre-processing. I focused a lot on feature extraction, which was my main sort of DSP focus there. Extracting like time domain and frequency domain features, and then playing around with what combination of features give the best accuracy. And then the machine learning component was obviously the clustering, the grouping of the samples.
So for people who may not be familiar with some of these terms you're using, when you say features, can you just describe to people what that actually means in the sense of machine learning?
Sure. So with audio, you'll need, if you're feeding it to a machine learning algorithm, you'll want some numeric descriptors of the sound so that you can differentiate one from another. Something that is very, very widely used that I was using is a feature called Mel frequency cepstral coefficients. And they're famously used with voice processing, but also with music. But they aim to approximate the shape of the vocal tract when you're singing or speaking. And by doing that, you can separate different sounds because your vocal tract will have a different shape based on like the phonemes that you're producing. But there's also simpler audio features in the time domain, like the zero crossing rate, which is just how many times like in a segment a waveform will go from positive to negative. And a nice way of getting a high accuracy with a machine learning algorithm can be to combine different features. And then you can get a bigger picture of representing those different sounds by combining their different features in the time domain and the frequency domain.
Got it. And you also mentioned the term unsupervised learning, and that's a big area of research. And I was wondering if you could just tell people who are maybe unfamiliar with that, the difference between learning on using a supervised method versus unsupervised.
Sure. So the main difference is that with supervised learning, you'll have labels that you're expecting. So you'll have target outputs. So say you had a neural network that was determining like hand-drawn numbers, what they were between 0 and 9. You're expecting an outcome from each of those inputs to be somewhere between 0 and 9. And each of those like images or whichever data you're using will have a label attached to it saying, this is what this is. But what you're trying to do is train the network to work that out for itself. With unsupervised learning, it's data that is unlabeled. So it's quite often used for things like customer segmentation in YouTube or Netflix, where they want to group customers based on their habits and then provide like recommendation algorithms. And the reason that I needed to use unsupervised learning for this project is that we are not sure what the users of Doubler are trying to emulate with their voice when they're training these triggers. All we know is that they're different in some way. Say they're training like kick, snare, and hi-hat. There's going to be like 3 different sounds in there. And what unsupervised learning can do can separate them based on how similar or different they are. And that is determined by how close or far data points are in a data space. And that's why I use clustering, because you can cluster things in a data space that have like inter-cluster cohesion and intra-cluster separation. So what you want is to see, like in a data space, if you were looking at those samples of kick, snare, and hi-hat, you're going to want to see like nicely spaced clusters of data. And that will only happen if you use audio features that well describe those sounds and well describe the differences and the similarities within them.
Got it. Got it. Wow. So, and you've learned all this in the past 3 years, huh?
Oh, we actually didn't cover machine learning on the course at all. That was all through Vochlea. And I had an incredible mentor, and still do have an incredible mentor, who just has really vast subject knowledge in this area. So I was lucky enough to work with them.
So one question that I had was that you did this research project with Vochlea. How did that manifest itself? How did that come about?
Yeah, so one day I got a message from the CTO of Vochlea on LinkedIn. They just found me via some connections, and they asked me whether I'd be interested in potentially working with the company part-time while I was studying, and with the idea of going full-time once I graduate, which was I was really honored to be messaged by them, and yeah, it led to this great relationship that I have now with the company. And at first it started off with just 1 day a week, so they were sort of sponsoring me during my final year of my MSc, and they gave me like a lot of free rein to just research and work on what I wanted to work on, with the idea that that research and work that I was doing would lead me to a job with them ideally, and lead me to building the skills that I would need to work with a company like that. And then we discussed the possibility of doing a master's dissertation that would have a mutual benefit for us both. So elements of what I'm interested in, what I'm passionate about, and also something that could potentially determine R&D at Vochlea in the future. So we just brainstormed together and came up with an idea that would be interesting to both parties. And for that time that I was writing my dissertation, I worked with them sort of part-time, and had mentorship from them at that time. So it was just really incredible opportunity, because you don't get many people able to work with a company on their dissertation.
And what was going into that situation like? Did you go into that and find that there there was a whole scope of knowledge just in terms of maybe even getting onboarded in terms of some I remember when I was studying, I didn't even really properly know Git management and
Yeah.
things like that. Did you find that there was a serious learning curve to those things for you? Or did you find that you got in there and that you were quite well prepared in terms of what you needed to know to get on board, clone a repository and get going?
Yeah, I realized that, like, as much as UWL did a great job in like designing the modules that they taught us, there's only so much you can cover. So we really didn't go into things like version control or Git or things like testing even. So, or even data structures. So just in my first 6 months there, yeah, I was learning how to use Git and the command line, and started doing some stuff with simple data structures, and it was all completely new to me.
If you had started again and you had your ideal learning path, or if you were to build a pipeline for the next generation of DSP engineers or audio developers, what do you feel are some of the more important fundamentals that people need to know about? Would you say data structures would be in there, or version control or testing, or what do you feel are some of the core fundamentals that people would need to know about to be an audio developer?
I would say, yeah, definitely things like version control and testing. It depends, I guess, what kind of path you want to go down, whether you want to be more of a DSP engineer or like more of like a pure C++ engineer. But if you are more interested in the DSP side, I would definitely say having those mathematical fundamentals I was talking about. And what else? Definitely the C++ standard template library. We really didn't go into that much.
Tamer shaking his head over there. Yes, testing, yes. Standard template library.
Tima doesn't agree. Oh no.
Oh no, he does agree.
Yes, I fully do agree. And testing and standard library are very good things that I spend a lot of time on. So
He
emphatically agrees, and Eyal agrees as well. So Eyal's given his thumbs up as well.
And the other thing is modern C++. We weren't really taught modern C++ as such. I just think, there's so much to learn, and that there wasn't enough time when you're taking people from having basically like no programming experience, and you're just trying to get like the fundamentals, conditionals and loops and stuff in there. There's not enough time to go over everything. But I have some really good recommendations for resources and stuff. I've got like loads of lists and things like that. If anyone's interested, they can reach out to me.
Yeah. Can you list some of the ones that were more influential for you?
So I did a course on Udemy, which might not be everyone's first choice for technical learning. I think it was called C++ from Beginner to Beyond. But it was just a really incredible overview of C++ with some really nice examples. In terms of books, you've got the ones I mentioned: Hack Audio, DSP First. Most people have heard of the Will Perkle books. They're really good. And I learned a lot of mathematics on YouTube, actually. I'm not ashamed to say it.
Yeah. Khan Academy got me through university.
Yeah.
It's amazing.
There's a guy, I think he's called 3 Brown, 1 Blue. I hope I've got that the right way around.
3 blue, 1 brown.
Oh, I think it's, the name's like a statistical thing.
Yeah, phenomenal.
And he makes incredible visualizations of mathematical concepts. And there's a really nice one on Fourier analysis.
That's right.
So like getting a visual idea of Fourier analysis is so important for learning it, for me anyway. So if you can understand that from like a visual perspective, then it's going to help you a lot. And I didn't realize that at first. I was just trying to understand stuff from textbooks. So yeah, I'd recommend them as well.
Amazing. So I'm going to go to a couple questions from the audience. Jesus asks, and I know you're kind of at the beginning of this journey, so I would understand if maybe you don't have the definitive answer for this, but do you have any advice on how to get an internship or part-time work in audio programming while studying? He said he's from Mexico City, so maybe location may be a barrier, but do you have any advice on how to approach companies and things like internships and that side of things?
Sure. So one thing that was really big for me was making sure that my LinkedIn was up to date. One thing that helps, I think, on LinkedIn is if you can develop your skills enough to a point where you can take the certification, because that looks really good on a LinkedIn profile, I think. And just to, you know, have it quite clean and have all your recent qualifications, or like an about you, which says, you know, your kind of goal, career goals, what you're interested in. But I think the main thing that I did was connecting with a lot of people that were already in roles that I wanted to see myself in. So if I had audio tech companies that I really admired or that I was interested in working for in the future, I would go and connect with people with influence within that company. So I'm talking CEOs, CTOs, anyone on the recruitment team. See if you can have a chat with someone that specializes in audio programming or audio development recruitment. And yeah, just put yourself out there as much as possible. Quite often things like internships aren't advertised on companies' job pages. So you can actually just write to a company saying how much like you admire the tools that they make and like what you could bring to an internship, that kind of thing.
Yeah. I think you brought up a great point, which is what you can bring to an internship. I think that's such a key piece of advice that can't be understated, because I think a lot of people that look for internships really think about what they're going to get out of the internship. But a lot of this when it comes to working with companies is about trying to fit a person who fits the right profile to the company, right? So if you're going to be working with a company like Vochlea, you know, a lot of machine learning stuff, a lot of digital signal processing, you know, versus, let's say, working at Ableton, working on Ableton Live, may then things like multi-threading and having great background in C++ and great understanding of the language and understanding, you know, so building a DAW would be not so much on the DSP side. So, you know, if you're building plugins and you're going for a forward-thinking plugin company, that's a match, because they're going to be looking at your CV and saying, hey, this person is building or trying to build the things that we're trying to build in this company, or similar types of things. So this is a match. So I think so many people forget about those things, and they really go in there, but they don't, like you said, is so important to show people what you're about. And if you don't keep some sort of public profile where people can see what you're up to, how can they ever discover you?
Yeah.
Yeah, there's nothing. You got to give people something to latch on to.
Oh, another thing, I wasn't very good at this personally, but when I started working with Vochlea, they got me up and running with this, but is having your projects on GitHub. So then like people that are interested in you have somewhere they can go and see your portfolio, I guess you would call it.
Yeah, portfolio is so important. It's like, if you're, what I always say to people is, if you told me that you were a painter, what would one of the first questions be that the person would ask? The person would say, well, show me something you've painted, right?
Yeah, absolutely.
Have anything that you've painted, tough to call yourself a painter, right? So your GitHub repository is kind of a reflection of that, isn't it? It's like, if you tell people that you're an audio developer, it's like, well, what audio apps or what audio plugins, what tools have you developed? If you haven't developed anything, it's very difficult for people to get an idea of what your capabilities are. You have to have something that people can latch onto and see. So
yeah, absolutely.
So there are some other questions here. Tugrel, and I apologize if I mispronounced your name. So going back to when you were talking about clustering,
Sure.
Tugrel asks, is this clustering runtime or offline clustering?
So it was a proof of concept for my dissertation. So that was offline. Okay. And yeah, I was achieving pretty high accuracy with offline, which is really promising. And one reason that I was doing this project is, if you've done machine learning projects, you'll know that if you're taking it real time, classification in real time, then you'll want to make this trade-off between accuracy and low latency. So within like what number of milliseconds you can make the correct classifications. And depending on the application, you'll want to make a trade-off on like, okay, how high does the accuracy need to be? And how low can we get the latency? So by that, I mean, for this, for example, like how many samples after the onset of the audio can you make an accurate classification on? And that's something that my dissertation really focused on, is like getting that low latency that would work well in real time. So I experimented with taking samples before the onset as well, because it's the samples after the audio onset that are the costly samples in real time. And when I say onset, it's like the beginning of a note event, or like the transient event at the beginning of a note. So yeah, what I might be working on at Vochlea is taking that real time, but the project is in Python and the application is in C++. So there's some workaround that needs to be done there, but that will be really exciting if that does get integrated into the application development at some point.
Sounds like fun. A question from Paul. He asks, from your current perspective, do you sense much of a difference between working on plugins versus working on applications?
I have very limited experience working on applications because I've just started working on the Vochlea code base. Maybe that plugin development is done more purely in JUCE, generally, and application development can bring in like other frameworks. But that's maybe literally the only difference I can see so far. And that might not even be correct for all cases. Okay. But I'm sure I'm about to find out.
Yeah. Cameron asks, do you have a recommendation for a good path to becoming educated on machine learning for a fellow DSP engineer? So any machine learning resources that you can recommend?
Yes, absolutely. The YouTube channel, The Sound of AI.
Yes. Valerio. He was on recently. Yeah, big shout out to Valerio.
He's incredible. He's like the machine learning version of you.
Yeah. He's really awesome, except he's much more technically skilled than I am. So actually, I'm more like the DJ Khaled of for people who may know who DJ Khaled is. Let's see. So I think that's it on questions.
Yeah, I think that's all the questions on the chat.
Yeah, great. Is there anything else that that you'd like to mention before we finish up, Rachel? That was very stimulating. Thank you.
Oh, you're welcome. I think I've covered everything I would talk about. Just to say, like, if there's anyone looking to follow this sort of career path or something similar, then my inbox is always open for people to ask me more questions about like how they could follow a similar path.
Yes. So how do people get in touch with you? So you have a cool Twitter handle?
Yeah. I don't use my Twitter too much, but I have a Twitter handle called Madame Modular, which is an ode to my love for modular synth. And I am Rachel Locke on LinkedIn.
That's Locke with an E at the end?
Yeah. I think those are the best ways to get hold of me, to connect on LinkedIn or message me via Twitter.
Yeah. Well, that's a very inspiring talk, and it's really awesome that we've come full circle in that you helped make it into the industry, and now you're the new co-host of the Audio Programmer Meetup. Who would have ever thought that?
Yeah.
So
amazing.
Yeah. Great. Okay. And with that, I think it's a good time to wrap up. So first thing I'll say is that we are looking for more talks and presentations on audio programming, and we're looking for talks of all different levels. So whether you're vastly experienced like Eyal or first stepping into the industry like Rachel, we are always looking for people to present their ideas and their perspectives on audio programming. And you can do that. And I will put the link in the description of the video below afterwards. It's the audioprogrammer.com/submit, or you can message Rachel or myself and talk about your wonderful ideas. And we'd love to hear them and get you on. Also wanted to give another shout out to our sponsors, JUCE, Focusrite, and Sonux. Thank you very much for your support for the Audio Programmer Meetup. And yeah, we're going to miss you, Teamer. I said I wasn't going to say that earlier, but we are going to miss you a little bit.
Don't worry. I don't think this is the last time I've been, I made an appearance on this meetup. Something tells me that I will be back at some point in some way.
Absolutely. Absolutely. And thank you very much, Eyal, for that awesome introduction to CMake. I think a lot of people really got a lot from that, myself included. So
thank you, Josh, Rachel, and Timur for having me. This was awesome.
Yeah, really good.
One thing that I think traditionally the co-host has been doing, so Rachel, that's going to fall on you in the future, is to remind Josh when exactly the next meetup is going to take place. So next meetup, the meetup is always on the second Tuesday of the month. And so the next one is going to be on Tuesday, the 8th of February at 18:30 UTC.
Yes. Yes. So yes, I will I will be on the lookout for anybody that wants to speak for that, and Rachel as well. And now it's awesome to have Rachel here with me, because any DSP topics I can turn over to her, and I can defer to her expertise, and she will be able to take things forward in a way that I would have never imagined. So that's really awesome. But for now, we will sign off, and thank you very much. 8th of February at 18:30 WTC is the next time we'll be on. Thanks, everybody. Hope you had a great time, and we will speak to you soon.
Bye, everyone. Thank you so much.
Bye.
Bye.
Okay, we've signed off.